So these are the solutions to the FIP quiz, and it seems like you all get that you subtract out the partial vapor pressure of the water. So again, I apologize, it cut off the side. So that's your 22 Celsius. The barometer in the lab, we're told, is 765 torr. So what we know is that the total pressure is equal to the pressure of the hydrogen plus the pressure, whoops, nice if you read it correctly, the pressure of the water. Which means that if we take the total pressure, P total minus the pressure of the water, we get the pressure of the hydrogen, the H2 gas, and we're given P total of 765.0 torr. We have to do a lookup on the water, and normally you would of course have a water vapor pressure chart that wasn't cut off. Sorry again about that. So minus 19.8 torr, and that gives you the pressure of your H2. So what we get for a raw answer, let me shrink this. What we get for a raw answer is 745.2 torr is the pressure of the hydrogen gas. Well, we only have 3 sig figs because of this. But, oh, actually, no, you know what? I'm wrong. I'm wrong. Why am I wrong? No. That number did not go into our calculation, though. If the number doesn't go into your calculation, it doesn't govern your sig figs. But this is addition and subtraction, and so the rule is decimal places behind the decimal. Places behind the decimal. So we're in the tenths place in both of these, so we can actually keep the whole thing. So we so often default to the rule for multiplication and division because it's what we use most. But this one would actually use the rule for addition and subtraction. So 745.24 is the pressure of the dry hydrogen gas. Questions, comments, concerns? 750 milliliters of gas is collected over water at 38 Celsius. If atmospheric pressure on the day of collection is 762 torr, what would the volume of the dry gas be at STP? And on that online quiz, I said this is a 2-part problem. So the first part is getting just the pressure of the dry gas, subtracting out the water vapor pressure. And that you guys are pretty good at, as evidenced in the previous problem. So you know that the total pressure is equal to the pressure of the gas. And we're not told what gas this is. It doesn't matter. It could be hydrogen, oxygen, nitrogen, carbon dioxide. We don't care. Plus the pressure of the water at 38. Again, my apologies. The chart got cut off, but the reading for 38, you'll see an 8 partway down, and it's 49.7 is the partial pressure of water at that temperature. So P total minus the pressure of the water is equal to the pressure of our dry gas. So we have 762.0 torr. Okay, so we've got the 762 torr minus, and I said it got cut off, but it's 49.7 torr gives us the pressure of our dry gas. So for that, we get a raw answer of 712.3 torr is the pressure of our dry gas. Okay, how many of you got that far on your own? Do you have the workout that you did on this quiz? Okay. And I think I know exactly where things went south. So we're going to kind of set that aside, because now what this becomes is a P1, V1, T1 equals P2, V2, T2 problem. As it has been brought to my attention, I'm recording this now, the problem that you did on the online quiz was slightly different. I had changed the temperature apparently, or I used a different copy. Sometimes I have multiple copies of the same quiz. Go ahead, if you want, follow along on paper on this. You see that the methodology is the same, right? Does that make sense? So the numbers are slightly different, but the methodology is the same. So follow along with the way you need to solve these. And then what I'll do is maybe have you go back and redo the FIP. And I can even change numbers on the FIP again so that it's a different quiz for you. Okay, so again, sorry, with different numbers. We get the pressure of just the dry gas. Now this becomes a P1 V1 T1, P1 V1 over T1 equals P2 V2 over T2 problem. Because you're going from initial conditions to another set of pressure and temperature conditions, and you're looking to find a final volume. So this is when we just want to go P1 V1 T1, P2 V2 T2. And I can tell you almost certainly where it went south. So we have initial volume. We have 750.0 milliliters. We have an initial temperature, which is 38 Celsius, which is 311 Kelvin. What is our initial pressure? It's the 712. It's the 712.34. You have to use just that pressure of the dry gas. So this is 712.34. What are your final conditions? So we're told that it's at STP. Do you remember what standard temperature is? 0 Celsius, which makes it 273 Kelvin. What's standard pressure? It's 1 atm, which in torr would be 760 torr. And that leaves us with the very thing that we're looking for, which is our final volume. So we'll set up our P1 V1 over T1. I've written down my equation. I've circled what I'm solving for. I'll now do the algebra. And I've got it all solved. I said it before, I'll say it again, I'll say it a bunch of times. Please, please, please rearrange and solve before you plug stuff in. Don't put in numbers and then solve. There are a number of reasons to do it this way. Not the least of which is it allows you to do that units check to make sure your rearrangement is correct. It also makes it easier to follow, if you do make a mistake, where that mistake occurred. Okay, so I'm going to plug in my numbers. So I've got everything plugged in. I can do my units check, and sure enough, torrs cancels torrs, kelvins cancels kelvins. I'm left with milliliters, which is really good because I'm looking for a unit of volume, and milliliters is a unit of volume. So my final raw answer would be 617.03, a whole bunch of stuff, milliliters. How many sig figs do I have? Two, because of that 38 that went in. So my final answer for this is going to be 620 milliliters would be my final volume. And that's significantly different. If you look at this, I had 750 milliliters of gas starting out. So if I want to compare at STP, it really does change the volume. Questions on this one? Did it go south where I thought it? So here's where I thought it went south. Here's where students usually trip on these. They don't put in that adjusted pressure for their P1. For how many of you was that the issue? Okay. You want to put in that full pressure for P1 rather than the pressure of just the dry gas. For how many of you was it setting up the final conditions using STP? Was that the other problem? Okay. And those are the two mistakes that people do typically make. I mean, all the other stuff in between is like, you know, I screwed up something in my calculator, I had all the right numbers, and something went bad. So, okay. Okay, so these ones are complicated because it's the two-step process, because you have to both understand the partial pressure piece and then doing your combined gas law conversion. Okay, last one you had on the quiz. Okay, this third problem. Now, of course, on the online quiz, it asked for the pressure in ATMs. I changed that. This is an older version of the quiz. And really all this is, this is also it's two things I'm looking at here. Do you understand combined pressures? So do you understand that P total equals P1 plus P2 plus P3? And can you convert those all to the same units? Whether those units are torrs or ATMs or kilopascals or whatever. Can you do the conversion? Do you understand that you can't subtract ATMs from torrs? That's what this problem is looking at. So what we're looking for, our final thing, is this pressure of the third gas. So if we rearrange this, P total minus P1 minus P2 is equal to P3. Okay, so now we're ready to do some serious heavy-duty converting. And even though the quiz you had online asked for this in ATMs, we'll go ahead and do this one in torr, just to kind of get you can convert back and forth and back and everything else. And I think on the online quiz I did give you, did I give you the conversion factors? No, but you were working presumably here or at home or wherever, so you had access to those. Okay, so we want this in torr. The total pressure is this 3.2. So 3.2, whoops, I just screwed it up right out, yay. 3.2 atmospheres, where 1 atmosphere is 760.0 torr. So that gives us 2,432 torr. Don't forget, and this is something that a lot of people do forget, you don't want to take sig figs until the very end. So you're going to keep all your numbers until you're completely done with the calculations, and you're only going to take sig figs at the end, because otherwise you're rounding all the way through, you lose a lot of precision. Okay, so we have to convert the total pressure. We got that one. The first gas is already given to us in torr. We don't have to convert that. And the second gas is given to us in kilopascals. So we need to convert that. So we have 81.9 kilopascals, where 101.325 kilopascals is 760 torr. So that gives us 614.3000518 on and on torr. And again, don't round that until you're completely ready, until you're completely at the end. So use that entire number when you're doing your subtraction. I'm going to shrink these two. Okay, so P total is 2,432 torr minus 806 torr minus 614.30, etc. torr, and that whole thing, we believe, is equal to the pressure of the third gas. That gives us a raw number, and actually I think this is maybe a better problem in torr. We get a raw answer of 1,011.699482 torr is P3. Now, how many sig figs do we get? 2. Why? 3.2. That 3.2 ATMs is going to limit us to 2 sig figs. How do you express 1,011, etc. in 2 sig figs? There's only one way to do it. Well, would that be rounding correctly? No. Okay? The only way to do it is scientific notation. That's the only way to do it. So it becomes 1.0 times 10 to the third torr is the partial pressure of that final gas. Okay. And I think it was actually a little bit easier maybe in ATMs. The problem wasn't as bad. What was the percentage of people who got that one correct? You did not get this one correct. And I know the answers are different units. But does it make more sense now that we do it together? Okay. The fourth one on there, I'm going to have you go ahead and do that as sort of a FIP right now. So Oh, if you didn't get one, here you go. So I'll have you do that fourth one as a FIP right now, and then we'll grade it in a minute, and then I'm going to give you some time to work on homework.